Good evening, YouTubers. I thought I'd bring to you today, since I'm studying C++ programming in my free time, an interesting concept of array sorting. I know this is a little bit outside of my usual Linux stuff, but I believe that in the best interest of serving a wider audience, there will be some fairly in-depth technical material on this channel. So without any further ado, I'm going to start talking about bubble sort. Bubble sort is not the most efficient algorithm for sorting an array. You might ask, why would we want to sort an array? And I guess one of the reasons why we might want to sort an array is that, say we have a group of like data, we might place that into an array, but we might want to find, and what I mean by like data actually is that of elements that contain data that's identical in type. So you might have integers, doubles, strings, or whatever. Now, what's important here is that some of the data that you get out there is not going to be sorted for you already, and further, you might want to find one specific aspect of the data, so or one part of the data. So you're going to have to do a search algorithm. Well, if you have to search the whole thing, well, that's going to take a long time. If you have like say 100,000 elements or something like that, it's going to make it pretty difficult to find. So sorting is an important technique to reduce the computation time for searching algorithms, because you do the sort, then you can do the search using some clever techniques. But anyway, so I'm presenting here bubble sort, and we can see here that we have this array here. I might highlight that in bold for the first part. So we have this array: 3, 55, 35, 24, 74, 45, 90, 9, 7 and 15. Clearly not sorted. So what we'll do is we'll look at what bubble sort does to accomplish sorting. So this is the first part. We have a main loop, and we have a set of minor loops. Okay, so and we also have the current array. So when I say green means that a comparison between two array elements was found to be valid. That is, 3 is less than 55. So that's okay, we'll do nothing and move on to the next loop. Next minor loop. 35 is, in this case, we found up here that 35 was before, it should be before 55, so we move it. Blue indicates a change to the array and where that change occurred. Likewise, 24 is before 55, so therefore changed into place. 55 is before 74, so that's fine, we won't change it. 45 is before 74, and so therefore we do change it. And likewise, we can go so forth and so on, until what happens is that 90 has been shifted as far to the right, since it is in fact the largest number. So then we move on to the next main loop, main loop 2. In this case, red text indicates that that element will not be inspected nor changed. So same here, 3 is before 35, so therefore no move. 24 is though before 35 and therefore is shifted. And you can see the pattern occurs here until 74 is the number that is to the right. And then what we do is that 74 will now be stuck in place. So now we have two numbers that have been stuck in place, and you can see that when we were in main loop 1 we had 9, because we had 10 elements, we had 9 comparisons to do. Then we went to main loop 2, we had 8 comparisons to do, and now that we're on main loop 3 there are 7 comparisons to do. The next step is to have a look at what happens now. We can see that we have a lot of numbers that are in the correct order, but when we find numbers that are not in the correct order, we will move them until again 55 is rightmost of the inspected and modified elements. And it goes on, and you can see that at each iteration there are less minor loops to do because there is one less element to check at each main iteration or main loop. We'll go on, and then we go on, and then we go on. Now, here's the interesting thing. In the last one, we have imported the array. Well, not so much imported it, but we have this value of the array, these sets of elements, and the value in these elements are by and far pretty much sorted, but not all of them. So what we do is we just check, and we find, in fact, they are sorted. We can't assume at the first step that they are, at the outset that they are, but we find that they are sorted. Now, what could happen is if you didn't write the program efficiently with bubble sort. Now, bubble sort, as I say, is not efficient necessarily compared to other sorting algorithms that I will probably detail in a future YouTube video. But what we should do to make it as efficient as possible is if there was nothing to sort in one main loop, we terminate. Bubble sort terminates. I'm now going to move on to explaining how it all works. So here's a C++ implementation using the same numbers that we had in our 10 element array. I'll just explain the program outright. I have not put any comments in here quite deliberately so I can explain it to you without you reading ahead. So IOStream is simply the input-output mechanism for standard input-output for C++, and the include statement just simply means include the header that will supply IOStream or input-output functionality in C++. It's a preprocessor directive, and there are others that such as CMath, such as FStream, such as C standard lib, but we're not going to go through that now. Using namespace standard is saying that all of the objects that are available in the standard namespace will be included. Some of these objects are cout, cin, and endline. The next that we have is the main bit. I should probably just add one thing here, that if you didn't have namespace standard, you would actually have to prepend standard to all objects or operations that required the standard, and you'd use that with std, and then you would use the scope resolution operator, which is a double colon, and then you would have to use something like cout if you're going to use it. So here is the function prototype for bubble sort, and I guess we'll go to that now and take a look at the actual function. Here's the signature line, which matches line 5. We declare a temporary integer, and that will be used for the swap routine when we have two elements, and you recall before that there'll be times where there are two elements that need to be swapped. So we need something to do that for us. So we'll have a temporary variable for that. And for the efficient termination of the program, we'll also have swap. We'll set it to true initially, and what we're expecting is that at each iteration there'll be something to swap, so therefore we won't terminate, but if it does go to false, that we never swapped anything, then we will break out of the main for loop and terminate the program, or at least terminate the function at that point. So we have the main iteration here, or the main loop, and what's going to happen is that its length is going to decrease by 1 each time. And so, in other words, we just go. It's. I should say the main loop will increase each time, but up to the length of the array. Well, up to the last element of the array, I should say. But then in here, we can see here that there is another aspect to the minor for loop, where we actually take into consideration the size of the iteration. So at the start, the size of the iteration is, or the number of the iteration is 1. So we'll take off 1 to the length each time, and that way we will not go over the bounds of the array when we go and inspect elements, but we will also decrease the size of the array at each major iteration. So, or at least I should say, we'll change the size of the inspection. This here is the swap routine. Sorry, rather not the swap routine, but rather is the swap check routine. Basically, if a swap is deemed to have not occurred, it's time to break out of the main for loop and terminate the function. And what we'll say at each step is because we return, or because we want to give swap equals true if a swap does occur, that we also want to set the trigger swap equals false back to false once we've inspected for false, so that it can be checked again to see whether it's true at each time. Again, as I say, with this minor for loop, we're going to be decreasing the size of the inspected array at each point, just by reducing the inspection length through each iteration. This here says, is the element to the left greater than the element to the right? In other words, the same question as asking, is this greater than that? And if this is greater than that, then we'll need to swap them. So the routine for swapping is to place the first or the leftmost or the left element into a temporary storage. You'll then take the right element and place its contents into the left element, and then you'll take the temporary element, sorry, the temporary variable, the temporary integer, and place it into the right element, thereby achieving a swap. We'll note them as a swap, but if this doesn't occur, then swap will equal false, and so therefore it will terminate out. Going back to the main part, we declare that the length is going to be 10, which is what this array is. It's a 10 in length array. You'll note too, though, in C++ that the last element in an array of 10 will actually have the indicator 9 because it starts at 0. The array starts at 0 going until 9, which is why we take into consideration iteration equals 1 here, so that we can take off from the length 1, so that we're only actually needing to inspect 8 elements, or in the first one 9 elements, and compare it to the first, then 8, then 7, then 6, and so forth. So basically, I'm just going to run this. There's this here is actually just the printing routine. It just prints out the array once it's been sorted, and this here just returns a 0 status to the shell, which says to it that the program executed without error. So what we have here is, I'm just going to compile the program, no errors there, and then we're going to do a bubble sort. And you can see that the elements are now indeed sorted. So I hope that from this you gained an understanding of bubble sort. Today it was new to me. There are other questions that might be asked about bubble sort. For example, how many iterations will it need? How many comparisons will it need before you know that the sort has occurred? If you, I guess if you don't terminate early. From my understanding of this, it's basically the following. I'm going to type it into the right hand terminal here. So if there are n elements, it'll be n times n minus 1 divided by 2 will be the number of comparisons that need to be made. Okay, so yeah, the reason why this is can actually be looked at through triangular numbers, which I'm learning about now. You can have a look on Wikipedia about triangular numbers and learn more about that there. Anyway, I hope you enjoyed this video. Please like and subscribe if you did, and if you need to add any comments below and gather a bit of a discussion about it, that'd be great. So anyway guys, have a good evening or morning or day or whatever you're having, and look forward to presenting another video soon. Good night.